Hi, good morning everyone. This is Mr. M from Algebra Lesson. Today in this video, I would like to share with you guys is about the exponential and logarithmic equations and how we can solve those equations in some simple steps. So, because of the time limit, I would like to use 2 or 3 examples for each and just explain well about this. So the first problem I would like to use is solve for x 3 to the power x is equal to 8. Okay, how can we solve it? It is saying that some value of x, some power of 3 is equal to 8. So we need to figure out what power of 3 is 8. If power is 1, 3 to the power 1 is 3, and if power is 2, 3 to the power 2 is 9. Oh, that means there is a number in between 1 and 2 satisfying this. Okay, we can figure it out. How we can do that? Okay, there are a lot of different methods, but we are discussing about exponential equation and logarithmic equation, so we can stick on this specific area. Okay, so if you have equations of this form and if you need to solve it, okay, you just start like this. 3 to the power x is equal to 8. See, one side you have an exponential term, the other side you have a regular number. Okay, no problem. What is our objective? Our objective is to figure out what is this x is. Okay, that means we need to isolate that x. If you have an x in the exponential part of a term, to isolate that x, your tool is applying logarithm. Okay, so what you need to do is apply log on both sides of the equation. So apply log. Actually, we will call it as natural log, but I'm just simply using here log with base 10. It is actually not making any big difference in its basic sense. So this is log of 3 to the power x is equal to log of 8. Because on both sides we are applying the same thing, it is actually not making any changes in the value of the equation. So, and now you can see that log of an exponential term. Here you can apply the property of the power rule. Okay, so here what will happen is the power comes in front of the log. So here the power is x, so in the next step you can write as x log 3. That is because of the power rule. Okay, is equal to log 8. Okay, now what is our objective? Our objective is to isolate x. That means we don't need this log 3. Log 3 is multiplied with x. So to eliminate a multiplication, you have to do the reverse operation of division with the same thing. So divide with log 3 on both sides. Okay, so cancelled out. So your answer is x is equal to log 8 over log 3. You are done. Log 8 over log 3. You can use your calculator and figure it out what is the answer for this section. So we figured out. I'm actually not worrying about what's the final result, but my objective was to isolate x from that exponential position. Okay, so moving on, we can discuss little more advanced problem. So another question I would like to share with you guys is, let me try to use a different color. Okay, I like pink. So the next question is 3 to the power x plus 2 is equal to 5 to the power 2x minus 1. Okay, see here this is also an equation. It is saying that some power of 3 and 2, sorry, not like that. Some power of 3 is equal to some power of 5. Interesting. Why that's like that? We can just try to figure out what is the power that is making these 3 and 5 is same. There may be values. Okay, we can try. Okay, so as I told you before, if you have a question in front of you like this, your tool is log. So apply log on both sides. Okay, so what will happen is log of 3 to the power x plus 2 is equal to log of 5 to the power 2x minus 1. Okay, and in the previous problem I said the power rule, so this x plus 2 will come in front of log, so x plus 2 log 3 is equal to 2x minus 1 log 5. Okay, so now in the next step what you can do is you can open the bracket, just simple arithmetic. You can open the bracket, that is x log 3, that means this out term with x, and again plus outer term with this 2 log 3, and this is equal to 2x log 5 minus log 5. Okay, so that is the expansion. Now combine the like terms. This is simple arithmetic, nothing more. So combine the like term in the sense combine the term which includes x. So this is x log 3, and here on the right side we have a term consists of x, that is 2x log 5. This is positive, so on the left side this become negative. 2x log 5 is equal to minus log 5, and here we have a 2 log 3, so this is minus 2 log 3 minus log 5. Okay, and in both terms you have x common, take it out. So because our objective is to figure out or isolate x, so this is x log 3, sorry, x times log 3 minus 2 log 5 is equal to minus 2 log 3 minus log 5. So that is the step before your answer. What is our objective? Isolate x. So we don't need this section of the equation. To isolate it or eliminate this section, divide on both sides with the same term. So the term will be x is equal to minus 2 log 3 minus log 5 divided by log 3 minus 2 log 5. So this is actually the solution, and if you need the approximation you can plug this in the calculator and figure it out. So that will give you an approximate value. I believe the approximate value in calculator comes around approximately 1.79. So we are actually not looking for this approximation. As a teacher I am always looking for this simplification and this process of isolation. Okay, so that's actually about that problem. And in the same section I would like to share one more problem, because that will make more sense. Suppose if we have a problem of that, this is kind of not a higher level problem but kind of a middle level problem. So solve x to the power square root of 2 is equal to 23. This is an interesting question. How we can do it? The same process, nothing more, nothing less. So log of x to the power square root of 2 is equal to log of 23. So at this point you can use the power rule of logarithm. So this is square root of 2 times log x is equal to log 23. And we need to isolate x. So first isolate log x. So for that you need to eliminate root 2. So from this, log x is equal to log 23 over root 2. Yep. And we need x. X is our priority. So because log x is equal to some quantity, then x will be log inverse or inverse log of this term on the right side. So to get the x quantity, x will be equal to inverse log of, okay, inverse log of what, or log inverse you can write, inverse log of log 23 over root 2. This is the answer. This is the kind of simplification I will look as a teacher. So that's about the exponential functions. Okay, now we can discuss something about logarithmic functions, because the heading was exponential and logarithmic functions, so I don't want to avoid logarithmic functions. So we can try to solve some problems from the logarithmic equation. So if we have a function of the form log x square minus 4 minus log x plus 2 is equal to 2. See, this is a log function. We need to solve for x. That is interesting. In these kind of problems, first you need to check with the question itself whether it is actually in the form of some property, or can we straight away apply some kind of properties on the question. Those are the things you have to think. That means what I need to figure out. That's the question as a student you have to think about always, and what information you have. Okay, that should be your strategy while approaching these kind of problems. See, in this problem or in this question, I can see that this is in the form of log a minus log b. I know that log a minus log b is log a by b. That is the Gaussian rule of logarithm. So I will rewrite this as log of x square minus 4 over x plus 2 is equal to 2. Yep, it is like that. Okay, and I forgot to write the base. The base of this is 3, and this is also having base 3, so this base also will be 3. Okay, so we can simplify this quotient. So that is log of x square minus 4 you can write as x plus 2 into x minus 2 over x plus 2 is equal to 2. You can cancel out x plus 2 from both ends. So your equation is log x minus 2 is equal to 2. Here the base is 3. And we need to figure out x. That means we need to isolate x. For that, first we need to eliminate this log. How can we eliminate a log? So to eliminate a log, you have to apply exponential function. That is not the case of application. Convert the log function into an exponential function. Okay, so how can we convert? I believe you already passed that area to convert the log function into an exponential function. So this is the method. So the base, keep it in mind, this base here, the base is 3, so the base on the other side will come as 3. So this can be write as x minus 2, because this is a term is staying on the left side, and the right side will change as is equal to the base is 3, so 3 to the power, the number written on the right side is 2, so this is your answer. So just I'm writing here. So the equation is x minus 2 is equal to 3 square that is x is equal to 3 square plus 2, that is 9 plus 2 is 11. So the value of x satisfying this equation is x is equal to 11. So that is the way you can figure out the logarithmic equation. I hope this makes sense for you guys, and if you still wish to watch more videos of the same kind or the topic that you wish to watch in your grade level, please don't forget to share this video with your friends and don't forget to subscribe my channel. And I'm signing off from this video. See you soon next time with another video. Thank you and bye.